Dear students, welcome to myclass.com. In this video, we are discussing about selection sort, its concept, its algorithm, and also analyzing the algorithm. So let's start. Selection sort is an in-place comparison based algorithm like our insertion sort and bubble sort. Selection sort also an in-place algorithm because we are not using lots of memories up to our array space or extra memory more than our array space we are not using in the selection sort, because it is also an in-place algorithm because it is not using much more extra memory space for sorting, and also a comparison based algorithm. We are comparing the elements and we are swapping the elements, like that and selection sort is working. So in which the list is divided into two parts: the sorted part and at the left end and unsorted part at the right end. Our assumption is like in the left side we have the sorted part and in the right end we have the unsorted part. So initially the sorted part is empty and we are considering whole list is in our unsorted part. Then the selection sort is starting like we are comparing all the elements and finding the smallest element among from the unsorted array and swapped with the leftmost element. Then when we are starting selection sort, first we will find the very smallest element and swap that element with the 0th index value, very leftmost element. Then that element is we are considered as the sorted part and the remaining is our unsorted part. So when in the remaining we are again checking and finding the next smallest element and swapped with the first index value. Like that the selection sort is work. Now we are checking the selection sort algorithm. In the selection sort algorithm, the main function is finding the smallest element. So we are maintaining a variable min for saving the index of the very smallest element in the array. So set minimum to location 0. So we are starting the searching from 0th index. First we are assuming that this is our very smallest value. Then search the entire element in the list. And we are finding the entire, we are searching the entire element and we are finding the actual smallest element in the list and we are swapping this with our 0th index value. Okay. Then increment to the next pointer and repeat the same step. Like that we are repeating this all step until our list is sorted. Now let's check the selection sort algorithm. A is the name of the array and n is the total number of elements in the array. In this example, this is 7. We have maintaining two loops in selection sort also, like our insertion sort and the bubble sort. So our first loop is a for loop. Repeat step 2, 3 and 4 for k equal to 0 to n minus 1. So it is working up to k equal to 0 to k less than n minus 1. That is 0, 1, 2, 3, 4, 5, up to 5 it is working, because k equal to less than n minus 1, in this example k less than 6, so up to 5 the outer loop is working. So in this outer loop 3 steps are repeating: step 2, 3 and 4. Step 2 is we are setting a min value. We are setting our min value to according to k. So here min equal to 0. In first case min equal to 0. Then we are starting the inner loop. There is also in for loop ptr equal to k plus 1 to ptr less than n. In this example, when k equal to 0, our inner loop is working up to 1, 2, 3, 4, 5, up to n means n minus 1, 1. ptr equal to n minus 1, 1. ptr equal to 6. Okay. So 6 times, when k equal to 0, 6 times the inner loop is working. Total outer loop is working at n minus 1 times. Okay. 0 to 5. So what is the working of inner loop? In the inner loop, we are setting our minimum value with k. So a of k is our minimum value. When we are assuming that a of k is our minimum value, in this example 45 is our minimum value, then we are checking all the other elements with the ptr value. What is going on inside the inner loop? That is, according to the ptr value, we are checking a of ptr with our a of minimum value. Our a of minimum is a of 0 in this first case. So we are checking all the other elements with 45. If A of PTR is less than A of min, then we are changing the min value to PTR, set min equal to PTR. So in this case, only 56 is not smaller, 98, 66 and 47 also not smaller than 45, 32 is smaller than 45. At that time, we are changing our min value to 5. Then again we are checking because we are up to n minus 1, up to 6 we are working the inner loop. So A of 6 is less than A of 5. We are checking again. No. So our actual minimum value among this list is A of 5. Then the step 4 is if min not equal to K, then swap A of K and A of min. Here we have found the actual minimum value. So that is not equal to our assumed minimum value. So we are interchanging. So we got that our minimum value is 32. Then we are swapping with the very first value because we are starting from K equal to 0. Next we are again doing the same thing when K equal to 1. So we are checking with the 56, 98. We are checking up to 98 to 47. So this process we are repeating until the list is sorted. That is a working of selection sort. When K equal to 0, our inner loop is working 6 times when the PTR value from 1 to 6. Is it? What we are checking inside the inner loop, we are checking if 45 or 56, which one is smaller. Here, first we are assuming that 45 is the smallest element. Like that, we are starting. That is, we are setting min equal to K. Okay. So here min K equal to 0. Then we are checking with 45 and 98. No, 45 is the smallest element when among these two elements. Then 40, again checking with 66, then 47. In this 32 is minimum, then 32 is less than 45. So we are updating new min equal to PTR. Our PTR value is 5. Okay. In the next step, we are checking 32 or 47. Which one is smaller? Again, 32 is the smallest one. So we got min equal to 5. Now we are swapping A of 0, A of K with A of min, A of 5. Okay. So we are swap 32 is here now and 45 is here now. It is the case of when K equal to 0. When K equal to 1, we are starting with, we are setting that 56 is the smallest one. Then we are starting with PTR. That is our our inner loop is up to 2 to 6. So 5 times the inner loop is working. We are checking with 56 and 98. No, 66 also greater than 56, but 47 is less than 56. So new min value is 4. Okay. Now we are checking with 47 and 45. So the new min value is this value, min equal to 5 now. Now we are checking this this value and this value. So here also we can find that 45 is the smallest. So we are swapping A of 1 and A of 5. We got our minimum as at the location at the index value 5. Is it? So we are swapping A of 1 and A of 5. That is 45 is here now and 56 is here now. When K equal to 2, we are checking 98 and 66 first. 66 is the smallest, then checking 66 and 47. Now 47 is the smallest element, then 47 and 56, but 47 is the smallest one. Then 47 and 47, but 47 is not less than 47, it is equal. Now we have got that our min value is 4. Now we are swapping A of 2 and A of min, A of 4. A of 2 and A of 2 and A of 4. 47 here and 92 here. When K equal to 3, we are starting comparing 66 and 98. 66 is the smallest value. We are not changing the min value. Then 66 and 56. So 56 is the smallest value. So min is changed to 5. And we are checking 56 and 47. Now we got the new min as 6. So we are updating. We are swapping A of 3 and A of 6. A of 3 and A of 6. We are changed 66 to here and 47 to here. Okay, now we got this. So this is our sorted part and this is our unsorted part after when K equal to 3. Then when k equal to 4, we are checking 98 and 56. So 56 is the smallest one. Then 56 and 66. Then also 56 is the smallest one. So we are changing a of 4 and a of 5. So we are updating 56 to here and 98 here now. Then when k equal to 5, we want to check only one time. Only we are checking PTR equal to k plus 1, 6. So we are checking one time. So 66 is the smallest one. So we are updating 66 and 98. So after the working of when k equal to 5, we will get the all sorted list. We will get the array is in the sorted order. So that is the working of selection sort with the example. Now we are going to calculate, or we are going to analyze the selection sort code. Okay. So the algorithm you can write like this in the C program. Is it? So our our two loops are here. So when we are considering the insertion sort and bubble sort, what is the best case? Best case of insertion sort is order of n, and also the bubble sort is order of n. Worst case is order of n square and order of n square in the bubble case also. So average is also order of n square and order of n square. Now we are going to calculate the best case, worst case and average case of selection sort. But when we are considering the loop working of selection sort, we can't identify a best case, or we can't breaking after some process for a best case in the selection sort. So this is the best case when we are considering. So we want to sort it in an increasing order, and our array is already in a sorting order. That is the best case of insertion sort and bubble sort, is it? According to the selection sort process, we can't minimize the time according to our array value, because our selection sort working is like that. We are setting one value as a minimum value, and we are checking all the elements, and we are finding the smallest one. So for the best case, this is the smallest one, but for getting which one is the minimum value, we have to work all the internal loop working, is it? So for best case also, the selection sort, all outer loop and inner loop should be completely done. For selection sort, the best case, worst case or average case, all are same. Let's see. Okay, so what is the worst case? So worst case is like this. In the worst cases, it is in the opposite order. Our input array is in the opposite sorted order, and that is in decreasing order, and we want to sort it in the increasing order. But in this case also, our selection sort work is same, because we want to do all the outer loop working and all the inner loop working, because we want to set this is the minimum, and we want to check all the elements, and we want to swap. So only the difference is the swapping is not required. This only this step, this little bit time is only we want to minimize. So for that, for the outer loop working, this is only to be we can avoid for the best case. So let's analyze the code. So our loop is working like this. Our loop I equal to 0 to I less than n minus 1. That is 0, 1, 2, 3, 4, 5. In this case, our n equal to 7 in this case, is it? So when I equal to 0, this all should be work. So it is working. This is for a constant time is for this portion, so we are avoiding, and here also a constant time is required, so we are avoiding. So we are only checking the how much time is required for our internal loop working, how much time our internal loop is working. So in the internal loop is working up to j equal to I plus 1. So j 1 to j less than n, that is j less than n means up to 6. That is 6 times it is working. 6 times we can generalize like n minus 1 times. Okay. Now when I equal to 1, our inner loop is working up to 2, 3, 4, 5 and 6. That is 5 times. So we can write it as n minus 2 times. Okay. So when I equal to 2, it is working 3, 4, 5, 6. 4 times, that is we can write like n minus 3. Okay. So in this case, 4, 5 and 6, 3 times. we can write maybe 3, or you can write like that n minus 2. Okay, so 3 here, 5 and 6 2 times, plus 2 here only one time, working up to 6, so plus 1. So here we can generalize it as like n minus 1 plus n minus 2 plus n minus 3 up to 2 plus 1. Okay, so this is the summation series of natural numbers up to n minus 1. So the result is n into n minus 1 by 2, n square by 2 minus n by 2. So we are only taking the biggest term. So our complexity is order of n square. So the fourth selection sort, our best, worst and average case complexity, average time complexity is order of n square. Hope it is clear now. Thank you for watching our video.